Hello everyone and welcome you all. So today we are going to solve the problems on suddenly applied load. As we know, there are three types of axial loads. One, it will be gradually applied load. Second one, it will be suddenly applied load. And third one, it will be impact load. So whatever the previous problem we have solved, they are all on gradually applied load. Now in this class we are going to discuss what you mean by suddenly applied load and their problems. So in a suddenly applied load, the load it will be applied suddenly without impacting the element or without impacting the bar, that we call as a suddenly applied load. So in a suddenly applied load, whatever the stress it will be produced in the suddenly applied load, it will be twice that of the same load which is applied in the gradually applied load. It means the sigma it will be double here, means 2 sigma you can consider here. Whatever the value of stress it will be produced, that will be twice here. That is the one of the important thing you have to remember in case of suddenly applied load. Now in this problem, how you can identify is it an gradually applied load or suddenly applied load, and the impact load you have to identify first. So in the question they may be given clearly. So now let me read the question. Find what direct tensile load. So here you need to find the load. Okay, so let us take the load as P. We will say P is the load. You need to find that load. If the load it will be applied suddenly, applied on a bar. Okay, so it is a case of suddenly applied load. Okay, now on a bar means it is a circular bar having a 45 millimeter diameter. The diameter it is given like small d will take as diameter for the element of 45 millimeter diameter, and the length is also mentioned L. So L is the length, will take as 3 meter, so it will be around 3000 millimeter. Okay, because all other dimensions to be taken in millimeter, because the stress is also given in millimeter and extension is also given in millimeter and also diameter. So majority of the parameters are in diameters, are in millimeter. Okay, so better go through all dimensions in millimeter. Now 3 meter long we have already converted. So it will cause an instantaneous extension. So this instantaneous suddenly extension means elongation, that will be delta L. Total extension it will be taken as delta L, that is 1.5 millimeter. Delta L will be the change in length, so that is 1.5 I am given, and anyhow Young's modulus is 2 into 10 power 5 Newton per millimeter square. Okay, so now all the dimensions and the question is clear to you. So you need to find the tensile load, that is P, if it is an suddenly applied load. As I told you, the stress it will be twice here. That thing you have to remember. Other than that, there will be normal procedure. So you need to calculate that. So first, to calculate the stress you require the area. So first calculate the area for the element 1, that is pi by 4 d square, it means 45 square. It is pi by 4 into 45 square, 1590.4 millimeter square. Unit of area will be millimeter square. Okay, so after that you need to find the P in this question. So now as we know, the equation for stress. Okay, so where Young's modulus, if you take Young's modulus is equal to what? Stress by strain epsilon will write. So again further it can be modified. Stress is equal to stress by strain it can be delta L by L. Now this equation become sigma L by delta L. Now again if you modify, delta L is equal to sigma L by E we can write. Okay, so if you know directly you can write where stress is equal to E into epsilon. Directly you can write this equation. Okay, so if you don't know, just go through the fundamental equation from the Young's modulus, then this will be modified one. Okay, so now what do you know about stress? So stress, as I told you, it will be twice. Okay, means 2 into sigma again into L divided by E. Sigma is equal to 2 into sigma. In suddenly applied load, it should be taken as twice than the gradually applied load. That I have did. So sigma I have replaced with 2 sigma. That's it. So now where 2 into sigma is what? It is the stress. Load by area is the sigma. So now again P by area we can write into L by E. Same. Okay, so this is all about delta L. So now in this equation we know delta L, we know we need to calculate the load, and area also we know, length also known, and Young's modulus also known. So only the unknown value is, that is P. So that we can calculate here. So now substitute what is delta L, that is 1.5 millimeter. 2 into P into L is 3000 by area is 1590. Okay, 1590 into 1590 in point something is there, 0.4 into Young's modulus, that is 2 into 10 power of 5. Okay, so now you need to find P. So what I will do, I will make multiplication of all these 3 into divided by 2 into 3000. It means around 6000 will be calculating now. 1590.4 into 2 into 10 power of 5 into 1.5 whole divided by 6000. 2 into 3000 you will get 6000. So we got 79,520. Okay, that will be in Newton, or you can convert in kilonewton also. It is 79.52 kilonewton. So this is the answer now.